Hello and welcome to day 2 of integrals. Last class we did basic integration. Now we're going to go to integration by substitution, which is called U substitution, which I just shortened to U sub. U sub is the reverse of the chain rule that we did in derivatives. So if we look at here, we're going to choose an appropriate U, usually the inside. Then we're going to find du, I'll show you that. Express all parts of the integral in terms of u. Take the integral, and then put back in terms of x. So let's look at what it means here. So the first idea is that we're going to choose the appropriate value for u. We are going to look right there at x squared plus 1. That's the inside. So we're going to let u equal x squared plus 1. The next part is take the derivative. When I take the derivative of u, I'm taking it with respect to x. So I'm going to get 2x. This is nice. 2x. We see that 2x is right here. We also need to see that there's a dx. Well, how do I get dx? Well, I have du divided by dx, because we took the derivative with respect to dx. So I'm going to multiply by dx to both sides. Those dx's are gone, and I'm now left with 2x dx, which, if we look, the dx is right here. So du equals 2x dx. The 2x and dx can now be replaced with du. The x squared plus 1 can be replaced with u. So therefore, I can now rewrite that integral as u to the 50th du. Why just du? Because the 2x dx is what du is. Now, this looks just like what we had been doing with our basic integration. The integral of u to the 50th is u to the 51 over 51 plus c. So we can go back to the original problem, put an equal sign, and say that the integral of 2x times x squared plus 1 to the 50th equals u, x squared plus 1 to the 51st over 51 plus c. And we are done. Let's look at the next one. We have to figure out what u is. U is usually what's in the parentheses, so we're going to let u equal x plus 9. Du equals 1 over dx, we can just put dx on this side. So you're going to get used to the fact that we're going to have du equaling something dx, or whatever variable we're taking the derivative with respect to. So now we can say that cosecant u, cotangent u, du. And you're going to go back and look at your integral from day 1 and realize that the integral of cosecant u, cotangent u, is equal to negative cosecant of u plus c. So I'll go back to the original, plug in what u is. This equals negative cosecant of x plus 9 plus c. So it equals negative cosecant of x plus 9 plus c. Done. So let's look at these last 6 here. U to equal the integral of sine 5x dx. So we'll let u equal 5x. Du to equal 5 dx. What we don't have is a 5 here. So what do you have to do? Well, when you have a 5 that's not here, I'm going to divide by 5. Because I need to know that du over 5 equals dx. I have to still replace that dx. It's du over 5. So I can rewrite the integral as sine of u was 5x, du over 5. Now, what is this really divided by 5? I can move that 5 to be a 1/5 out in front. So I'm really left with 1/5 in the integral of cosine. Sine is negative cosine, so we'll put a negative 1 out in front, of u plus c. And so our final answer will be the integral of sine 5x dx to be negative 1/5 cosine of 5x plus c. Why don't you try this next one, please? So pause it and try the next one. And so hopefully you got -3/4 with 1/3 x plus 8 raised to the 4th in the denominator plus c. The key here to knowing this is that we had to get rid of the 1/3, so we multiplied by 3, and realizing that u to the 5th can be moved to the numerator by making the exponent negative. So pause it if you need to, and we will then move on to the middle one. So looking at this next problem, notice that we have t to the 4th and the cubed root of 3 minus t to the 5th. So our u, we need to let our u be the inside of the cubed root. So we're going to go 3 minus 5t to the 5th. du will immediately do that, gives us -25t to the 4th dt. Don't forget the dt. And we notice that we have a t to the 4th and a dt that we need to get rid of, so we'll just divide by -25. So du over -25 equals t to the 4th dt. Now when we go to plug this back in, let's see what we get. We get -1 over 25. And then the cubed root, let's rewrite that as u to the 1/3 du. So now, let's take the integral of it. -1 over 25 u to the 4/3 divided by 4/3 plus c. And so we will state that that is 4/3 multiplied by the reciprocal. So we'll get -3 over 100 u to the 4/3 plus c. And know that we can rewrite u to the 4/3 as the cubed root of u to the 4th. Just know that we can do that. So when we go and write our final answer here, we get -3 over 100 u to the 4/3. So our u was 3 minus 5t to the 5th raised to the 4/3 plus c, or we can rewrite it as -3 over 100 of the cubed root of 3 minus 5t to the 5th, all raised to the 4th plus c. So either way will work. Key here, just knowing you had to divide by -25 and then multiply by the reciprocal when you divide by a fraction. So that's that one. Let's look at this one, and I'm going to start you and then I want you to try to finish it. Notice that you have an addition sign here. When you have an addition sign, that means split it up. Okay, so pause it and try to finish this one, and yeah, let's just do that one. Hopefully you remember that the integral of 1 over x is ln the absolute value of x, and then you got 1 plus 1 over pi, then tan of pi x plus c. So moving on to our last two problems here. Notice that we have the integral of sine of x all squared cosine of x dx. So the question that we have to think to ourselves is, what is u going to be? So I see the parentheses. I'm going to let u be sine x. So du will be cosine x. Dx. And let's see if that works. Does cosine of x dx fit right here? And the answer is yes. So, well, that was simple enough. I rewrote it to be sine of x squared, and then I let u be what was inside the parentheses. So we'll get u squared du. So that equals u to the 3rd over 3 plus c. Now let's plug in what that is. So we'll say that equals u was sine of cubed x, sine cubed x over 3 plus c. Done. Moving on to our last problem, e to the square root of x over square root of x. Again, I look and I say, oh, it's our exponent. We have to let u equal square root of x. Now, is this always going to be the case? No, but that's what we first attempt with. So what is du? Well, we know the integral, or the derivative of any square root is 1 over 2 square roots of x. And we need our dx at the end. So when we look at this, if I have the integral of e to the u, I need to get rid of this divided by square root of x and dx. Well, I almost have it here. I just need to get rid of this 2, so I'm going to multiply by 2 here to let that be du. So 2du is really equal to 1 over square root of x, the 1 over square root of x here, dx. So if you're having trouble seeing that, I could rewrite that as this to be the same problem. And then this right here is what 2du is. So I'm left with that, 2 integral of e to the u du. And I know what that is. That's just 2 e to the u plus c. And so our final answer will equal 2 e to the, what was u, square root of x plus c. And I'm done. So that wraps it up for today. That was basic u substitution. We will get into more difficult u sub problems, but for now we'll keep it in these. The math joke of the day is right here. The Creek cows say mew. Have a good one.